In this video, I'm going to go ahead and give you an integration by parts example. The integral is e to the power x cosine of x dx. As you know, the integration by parts formula, which is integral u dv is equal to uv minus integral v du. Now the substitution that I'm going to make here is going to be u is equal to cosine of x. So I'm assuming u is equal to cosine of x, and that leaves me with dv is equal to e to the power x times dx. Now if I take the derivative of u with respect to x, that's going to give me negative sine of x, right? And then my du is going to be negative sine of x times dx. And I'm going to take the integral of both sides here. So it's integral dv is equal to integral e to the power x dx. Integral of dv is just v, and integral of e to the power x is e to the power x. Now my integral e to the power x cosine of x dx, this becomes integral u dv according to my substitution, right? Which is going to be uv minus integral v du. My u is cosine of x, right? Cosine of x, and my v is e to the power x. So I'm going to write e to the power x times cosine of x minus integral v du. Now v is e to the power x, and du is negative sine of x dx. Now let me simplify it. What do I get? E to the power x cosine of x. This negative and this negative is going to make it positive. So integral e to the power x sine of x then dx. Now I have to use the integration by parts on this one. So let me go ahead and do that. So my integral is e to the power x sine of x dx. And I do the substitution as follows. So my u is going to be sine of x, and my dv is going to be e to the power x dx. And by now you know it's going to be du is going to be equal to cosine of x dx, right? And integral of dv is going to give me v is equal to e to the power x. I'm doing another u and dv substitution. So now this is going to be my integral u dv. So this is going to be this, according to this new substitution in blue, is going to be uv minus integral v du. My u is sine of x, so it's going to be sine of x, and v is e to the power x. So uv is going to be e to the power x sine of x, right? Minus integral v du. V is e to the power x, and du is cosine of x dx. So it's going to be cosine of x times e to the power x dx. Now this portion is actually equal to this. Now I'm going to go ahead and substitute this value here. Integral e to the power x sine of x dx. So now if I do that, I get, so don't forget this portion too, e to the power x cosine of x, right? Plus this, which is going to be e to the power x sine of x minus integral e to the power x cosine of x dx. Now please do keep in mind this whole expression came from this integral e to the power x cosine of x. So this must be equal to integral e to the power x cosine of x dx. Note that I started off here and I did the u and dv substitutions, and I got to this point, right? Now, after that, I did integrate this part and came up with this, and then I did the substitution, and this gives me that. Now, the left hand side here in this equation should be equal to the right hand side. So I am going to go ahead and add integral e to the power x cosine of x dx to both sides. Integral e to the power x cosine of x dx. And on the left hand side, these two are going to cancel each other out. And on the right hand side, you're going to get two of them, right? So it's going to be, so I'm going to write this here on the left. 2 times integral e to the power x cosine of x dx going to be equal to e to the power x. I just switched the side. Hopefully that did not create any confusion. In an equation, if I say a is equal to b, it is the same thing as saying b is equal to a, right? So I just took this right hand side and wrote it to the left. So now between these two, I could factor out e to the power x. That's going to give me cosine of x plus sine of x. Now if I divide both sides by 2, I'm going to get integral e to the power x cosine of x dx. That's exactly what we are looking for, is equal to 1/2 times this e to the power x cosine of x plus sine of x. And of course we have to add the arbitrary constant c. Okay, so that's the arbitrary constant. So this is how you will solve this problem. This is a two-step process. Remember, this is a two-step process. You use integration by parts twice here. One time I used it in black here on the top, and the second time in blue with the expression integral e to the power x sine of x dx. And then we put it together to get the final integral that we were looking for, e to the power x cosine x dx. I hope that this discussion was helpful. Thank you very much.